For a lighting circuit drawing 16 amps, a 20 amp circuit breaker is appropriate. The 1.25 rule, also known as the 80% rule, dictates that a circuit should not be loaded to more than 80% of its rated capacity. This provides a safety margin and helps prevent nuisance tripping of the breaker. In the scenario described, 16 amps is 80% of 20 amps, therefore a 20 amp breaker is suitable to protect the circuit. Using a larger breaker, such as a 30 amp breaker, would not provide adequate protection for the 16 amp load and could potentially create a fire hazard if a fault occurs. The purpose of the breaker is to protect the wiring and equipment connected to the circuit from overcurrent conditions. Now let's discuss voltage drop calculations. Voltage drop is the reduction in voltage that occurs along the length of a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To calculate voltage drop, we use the formula voltage drop equals current times distance times volts per 1000 feet, all divided by 1000. In the example provided, we have a 480 volts motor drawing 11.6 amps, with a one-way distance of 850 feet. Using number 6 wire, the voltage drop is calculated as 11.6 amps times 850 feet times 6 volts per 1000 feet, which equals 69.6 volts. With number 10 wire, the voltage drop is calculated as 11.6 amps times 850 feet times 10 volts per 1000 feet, which equals 98.6 volts. The allowable voltage drop for power circuits is typically 5%. For a 480 volt system, 5% voltage drop is 24 volts. In the example given, the voltage drop for number 6 wire, which is 69.6 volts, is significantly higher than the allowable 24 volts. The voltage drop for number 10 wire, which is 98.6 volts, is also significantly higher than the allowable 24 volts. Therefore, both number 6 and number 10 wires are unsuitable for this application as they exceed the allowable voltage drop limit. To reduce the voltage drop, a larger wire size should be selected. Let's consider number 4 wire. Assuming number 4 wire has a voltage drop of 4 volts per 1000 feet, the voltage drop would be 11.6 amps times 850 feet times 4 volts per 1000 feet, which equals 39.44 volts. This is still higher than the allowable 24 volts, but closer to the limit. Let's try number 2 wire. Assuming number 2 wire has a voltage drop of 3 volts per 1000 feet, the voltage drop would be 11.6 amps times 850 feet times 3 volts per 1000 feet, which equals 29.58 volts. This is also still higher than the allowable 24 volts. Let's try number 1 wire. Assuming number 1 wire has a voltage drop of 2.5 volts per 1000 feet, the voltage drop would be 11.6 amps times 850 feet times 2.5 volts per 1000 feet, which equals 24.61 volts. This is very close to the allowable 24 volts, but still a bit high. Let's try number 1/0 wire. Assuming number 1/0 wire has a voltage drop of 2 volts per 1000 feet, the voltage drop would be 11.6 amps times 850 feet times 2 volts per 1000 feet, which equals 19.72 volts. This is less than the allowable 24 volts and would be a suitable choice for this application. In general, it is recommended to use the smallest wire size that meets the voltage drop requirements to minimize costs. However, it is also important to consider other factors such as the ampacity of the wire, the ambient temperature, and the installation method. The ampacity of the wire must be sufficient to carry the load current without overheating. The ambient temperature can affect the ampacity of the wire, so it is important to select a wire with an appropriate temperature rating. The installation method can also affect the ampacity of the wire, so it is important to follow the manufacturer's instructions and the relevant electrical codes. To summarize, firstly, for the lighting circuit drawing 16 amps, a 20 amp circuit breaker is appropriate based on the 80% rule. Secondly, for the 480 volts motor circuit with a one-way distance of 850 feet and a current of 11.6 amps, number 1/0 wire would be a suitable choice to minimize voltage drop and meet the allowable 5% limit. Remember to always consult the National Electrical Code or local electrical codes for specific requirements and to ensure safe and compliant installations.